So welcome to our video here. What we're looking at is, in this case, solving for these different kind of figures. What we're looking at again is just kind of being able to solve for these parabolas, and we're going to talk about the AH and K value here. So basically what this is it's just kind of modeling real life scenarios that you might see in specific values. So in this case, obviously the AH and K, again, is going to kind of take front and center fold here. So we'll kind of jump right in and looking at these values. So with that, so what we're going to do is we're going to jump right in. So the diagram below shows a rabbit. In this case, it says the diagram at the right shows rabbit jumping over the 3-foot high fence. To clear the fence, the rabbit must obviously start a jump at a point 4 feet from the fence and sketch the situation and write the equation. So what you see here again is already the kind of situation kind of described for us. What I'm going to do though is I'm going to kind of draw that graph, so then that way again we kind of get a little bit more clear picture. So obviously, as you can see, the bunny kind of has that parabolic curve, so it looks like a parabola. And with that parabola, obviously we start that value and then we kind of end here. So the bunny jumps and then he ends at a certain point. Obviously gravity kind of brings him back down. So what we're looking at then is we're looking at how we can actually represent these as a curve. So if I'm looking, obviously before bunny starts, and again you can label these, this is the horizontal distance that he jumps. And then this is the height that he reaches on the y-axis, or again, vertical. So what we're looking at then is we're going to say, all right, well, we have the horizontal distance, and therefore he jumps. Obviously he jumps and he's going to be 8 feet, so that's going to be my x value. But if I look, what you're going to notice is in this case he has no height anymore because he's obviously finished his jump. So 8, 0 is going to be that point. Now where he starts, in this case if you're looking, obviously he's back here. Before he even jumps or does anything, he's going to be obviously at 0, 0. And then the most important point, what I'm looking at here is I'm looking at what we call the HK, aka what we call the vertex. Now the vertex again is the highest or lowest point of the parabola. Now if we're thinking vertex here, again, I'm looking at it and saying, well, the vertex obviously is going to probably be halfway in between those values, okay, for that vertex. So in this case, he obviously is going to hit that height of 3 feet at his apex, meaning the height of the jump. But in this case, how far has he gone horizontally in terms of when he hits the height of his jump? Well, if I look here, halfway in between the values of 0 and 8, I add those values up. 8 plus 0 gives me 8, divided by 2 is going to give me the value of 4, because in this case I can have the intercepts. So in other words, these are what we have as the x-intercepts. This is our vertex. Now, what we're going to do then is we're going to use this to write the situation in terms of the problem. So down here at the bottom, we're going to go ahead and write that formula for vertex form, which if you recall vertex form, just scoot down a little bit, is y equals a times x minus h quantity squared plus k. So what we're going to do here is we're just going to use that formula to be able to find the values. So in this case, we are already given that h and k value. What I'm going to do is I'm just going to plug it in. So I'm going to do y is equal to, parentheses a, and then x. Now, with that positive value 4, it's going to change to minus 4, quantity squared, plus the k value, which in this case is 3. So that doesn't obviously change, just goes into the formula. All right, so now what you're going to notice is we obviously have a couple more variables to look at. So in this case, x and y are just the variables that we always write. But keep in mind, though, that a value, stretch factor, we actually might have a stretch factor here. It could be a normal parabola, but we don't know. Assuming under normal circumstances, though, it's probably not going to be if a bunny jumps, obviously, within that parabolic shape. So what we're going to do is we're going to go ahead and plug in some values for x and y in order to solve for what we call the stretch factor. Now, with that, again, what I'm going to refrain you from is having you plug in that vertex point into the x and y, because again, those are already points we know. That's part of the parameter of what we have for a quadratic. So what I'm going to do then is I'm going to go ahead and take that x and y, so either 0, 0 or 8, 0, and I'm going to plug it in. The nice thing is either one of them works. What I always tell students, use 0, 0, because again, that's a little bit easier in your heads when you start to use them. So therefore, y is going to be 0, and then parentheses a, and then 0 minus 4, quantity squared, plus 3. All right, so now we got that. What we're going to do now is we're just going to simplify those terms. So therefore, 0 minus 4 gives me negative 4. Negative 4 squared gives me 16. So I'm going to have 0 equal to, and therefore, again, when I multiply, I'm going to have 16a plus the value of 3. All right, so as you can see, again, our terms, nothing too bad here. What we're doing is we're just basically taking that value 4, then we're squaring it, and we're just multiplying it with the 8. Now, to get it by itself, what we're going to do is we're going to take that 3, we're going to move it over, and I'm going to get negative 3 is equal to 16a. Divide by 16 on both sides, and the a value is going to equal negative 3 over 16. So again, that is the last part of the formula that we need to find. Because if you look, what we're doing here is we're just, again, solving for the a, h, and k. So now what I can do is I can just plug it back into the situation. So y is equal to negative 3 over 16, parentheses x minus the value of 4. So therefore I have minus 4 quantity squared, and then plus 3. So therefore, what we have is we have our equation there. So again, what we're doing, again, is just basically doing what we've done the entire thing, but now we're given a situation. So again, if you wanted to leave this as a decimal, that is totally fine. But again, what I'd recommend is just leaving it as a fraction because, again, it's just easier to write out, especially when you have the entire equation here as well. All right, so hopefully you had a good chance to understand that. We're going to go and flip on the back side here. All right, now it's going to ask you for 265. This is the same kind of problem that we just did for 265, so you do not need to do it. If you want to do it and find a value on here, that's fine, but you can just cross that one out, again, just so you know. And then with that, we're going to go ahead and model this one with Miss Bibby. So in this case, and oh, I forgot there was one more on the back side there. I was looking for it. That's where I was looking for my other problem. So Miss Bibby, 266, it says, when Miss Bibby kicked the soccer ball, it traveled a horizontal distance of 150 feet. It reached a height of 100 feet at its highest point, sketch the path of a soccer ball, and then find the equation of a parabola that models it. So what I'm going to do here is I'm going to take that same idea that I just did with the values for the rabbit, and now I'm going to do that with the soccer ball. First and foremost, I'm going to go ahead and sketch that graph, because again, when I sketch the graph, it just makes life so much easier. Again, we can label our axis, so I'm going to have the horizontal distance here. And then I'm also going to have the height, because obviously a soccer ball, when we kick it, hopefully should have height, as long as, again, they're a good soccer player. All right, so Miss Bibby kicked a soccer ball, and it's going to travel a horizontal distance of 150 feet. So again, if we sketch a ball path, again, assuming that she kicks it up in the air, it's going to have that parabolic shape. So initially, again, that horizontal distance, we're going to start at 0, 0, because in this case, the ball hasn't gone anywhere and has no height. And also, when the ball traveled the distance of 150 feet, in this case, again, that's going to be all the way over here. Okay, and now it's come to rest. So in this case, again, that's when the ball kind of comes down, stops dribbling, and boom, bounces down. All right, now, with that in mind, assuming that, again, it reached a height of 150 feet, what we're going to do is we're going to find that vertex point. The vertex point halfway in between the values for the x, and then again it reaches that height. So I'm going to write that coordinate, and that coordinate obviously is 100 feet here for y. Now for the x value, this one again is a little bit more interesting because now it's going to be again halfway in between 0 and 150. Some of you may know halfway in between 150, which again, if you think of it as money, $1.50, we have 3/4 there, that's 75 cents. So in this case, the value is going to be 75 there, so halfway in between. You can also do 0 plus 150 and then obviously add them and then divide by 2. So with that, we're going to go ahead and plug in our values for what we know for the, again, vertex form for a quadratic. All right, so we got y is equal to a times x minus h quantity squared plus k. So I'm going to go ahead and plug in my vertex there, which I know is 75, 100. So y is equal to a and then x minus 75, so it changes that value, quantity squared, plus 100. Then I'm going to take my x and y points, which again, if you want to, you can plug it all in one. I just want you to make sure that you see where, again, the vertex points are coming from. So I'm just going to plug in the value of y and x as 0, and then solve for a. So 0 is going to equal, parentheses, a, parentheses 0 minus 75, quantity squared, plus 100. All right, so now, nice and easy, what we're going to do then is we're going to simplify. So obviously I have a out here. I'm going to do 0 minus 75. Negative 75, obviously, and then when I do that, I'm going to get that negative 75 squared. That one I do all off the top of my head, so I'm going to go ahead and plug that in. Make sure that you have the parentheses around it. Hit enter, and you're going to get a value of 5,625. A, so 0 equals 5,625. Yep. A, and then plus 100. So again, just using your order of operations there. Next part, we got that value of positive 100. I'm going to subtract it. So I'm going to get negative 100 equal to 5,625a. And then you're going to divide, obviously, by 5,625 on both sides. Now, keep in mind, obviously, this is a big fraction. So I'm going to show you how to, again, simplify it. We did this in Chapter 1, but again, just in case you forgot. So I'm going to take that value, and I'm going to do the value of negative 100. And I'm going to divide by the original answer. So that one, again, is saved here. So I'm going to go second negative. There's my answer. Now, it's going to come out to be that long decimal. Again, if I don't want to write that decimal, obviously, again, it is kind of messy, especially with the repeating digits there. I'm going to go ahead and hit the math button, and then I'm going to hit fraction. So remember, what this is doing is it's taking that answer from the previous problem, and it's going to simplify it into a fraction form there. Hit enter. Here's your simplified fraction. So negative 4 over 225. So therefore, we write it out. And then what I'm going to do is I'm just going to write out the rest. So therefore, y is equal to negative 4 over 225 multiplied by the value of x minus 75, 180 squared, and then plus that k value of 100. So here is my final form for that vertex there. All right, so as you can see, again, nothing too big. What I always tell students is just make sure that you understand the vertex, plugging that in first, and then being able to plug in the x and y values to do so. All right, so with that, that's our second problem. We're going to go ahead and do the third problem on the back side. What I tell students is, again, if you're feeling comfortable, feel free to go ahead and take a look at it. So then that way, again, you can solve. Now, this one's going to be a little bit more interesting because what you noticed here with the previous problem and the one before that is, again, both of these parabolas were obviously shaped like a parabola that's opening up, or excuse me, opening down. And since that's the case, what you notice is that a value is going to be negative for both. Now, what we're talking about here is it's saying now at a skateboard park, the hot new attraction of the U-dip. Okay, so think of like when you go to the X Games, again, you got those huge, trying to think of the correct terminology for it. You got the half pipe, excuse me, so you had a half pipe. The cement structure embedded in the ground. The strong sectional view or cross-sectional view of the U-dip is a parabola that dips 15 feet below ground. The width of that ground level is the widest part. It is 40 feet across. Sketch the cross-section of the U-dip and find the equation of a parabola. So, again, assuming that we have, again, the thing that looks something like this, okay? Again, what you're going to notice is when we sketch this, obviously we're going below ground. So when I have this, again, pretending this is my axis, this is level ground, I know this is going to be 0, 0. Okay? Now, with that in mind, here's your height. And then here's your value, so it's the horizontal distance traveled. Now, with that in mind, what we're going to do is we're going to sketch this problem. So it says the cross-sectional view of the parabola dips 15 feet below the ground, so we're going down, and then we come back up. So it says the width at ground level, its widest part is 40 feet across. So assuming that, again, this is 40 feet across, it's going to be 40, 0, because, again, it's going to be kind of back at ground level. Now, if we're looking at, again, this cross-sectional view, this is our vertex, the one that hits the lowest point. So now it's opening upward, okay? So we have that parabola. Now, if we're going to write the HK value for this, what I'm looking at is I'm saying, all right, well, we obviously have that thing being 15 feet below the ground. So if I'm below, obviously right away we know that's going to be a negative value of 15. And again, that's going to be the K, obviously. And then the positive H value in this case is going to be halfway across. So therefore, 40 and 0, halfway in between those is going to be 20. All right, so now we got 20 and negative 15. What we're going to do is we're going to take that idea for the vertex, and we're just going to plug it in now for the vertex form. So y equals a, in parentheses, x minus quantity squared, x minus h quantity squared plus k. And then I'm just going to plug in my vertex, which is right here. Y is equal to a, and then parentheses, x minus 20 quantity squared, and then minus 15, because again, we have that negative k value there. All right, so now what we're going to do is we're going to go ahead and keep simplifying. So in this case, what I'm going to do here is I got that a value. Obviously, this one's negative. I'm going to go ahead and plug in my other x and y point, 0, 0, or you can do 40, 0, depending on what you want. 0 is equal to a, and then with this one, 0 minus 20, quantity squared, minus 15. And then I'm just going to go ahead and solve for my a value. First things first, I'm going to simplify everything with that squared term. So I'm going to have 0 is equal to, so 0 minus 20 gives me negative 20. Negative 20 squared gives me 400, multiplied by a is just 400a minus 15. And then you're going to take that negative 15, move it over. 15 is going to equal 400a. And then we're going to have that value. So we're going to divide by 400 on both sides. And our a value is going to pop out to be the following. So in this case, 15 divided by 400. I'm going to go ahead and do it in that calculator there. Same thing, if I divide that, I'm going to get a nicer decimal. So again, if you want to put that, feel free. Otherwise, what we can do is we can just hit the math button, fraction, hit enter, and then we have the simplified form. So therefore, 3 over 80 there. I know it's kind of hard to read. So we can put that as our a value. Last but not least, we just write it out in vertex form. So y is equal to a value, so 3 over 80, parentheses x, and then minus 20, quantity squared, minus 15, and we get our final form. And again, since we're again talking a positive value, since it's opening up, again, we know we did it correctly there because our a value is able to do so. All right, so hopefully, again, you're able to, again, solve these. We're going to be going over our toolkit next time I see you, obviously, so therefore, again, we'll get some practice with this. Again, students usually do very well with it. Again, I think because, again, we look at vertex form a lot, so therefore, we're able to, again, be able to kind of apply it with it. All right, otherwise, have a great rest of your day, and I will see you all soon. Make sure, again, let me know if you have any questions.